So in this question, we're given a function of x that's the natural logarithm, and we're asked to sketch that. So sketching the natural logarithm, you need to remember that x, the domain of x, is x greater than or equals 0, or greater than 0. X cannot be 0, and it cannot be negative. So there's an asymptote at x equals 0, and it passes through the point 1, 0. And that is f of x. So that is part A. Now, the question goes on to ask for the modulus of f of x, that's the absolute value of every point here, and then f of the modulus of x. So let's look at B first. So the modulus of f of x means every point here on the graph must be positive. So all the negative points are converted by the modulus function to positive points. So your graph originally looked like this. Now all these negative points will be reflected upwards and converted to positive points, and the negative parts will all be removed. So we can remove this. Let's turn that into a dashed grey line. So this is part B. That's what the modulus function does. It reflects on the x-axis. So everything beneath the x-axis is reflected upwards. Whereas if you take the modulus of x, that means that x, whether it's positive or negative, is treated as negative. It's treated as positive. So when x is positive, we have the same function. But when x is negative, it's treated as if it were positive. So the negative value here, if you put in a -1, if you put in x as -1, it will be treated as f of 1. So these points are reflected. So it's a reflection on the y-axis. But both of these remain. If there was anything here, we would remove it and replace it with what we reflect on the y-axis. So that is f of modulus x. So whenever you have a modulus outside the f of x, you reflect on the x-axis upwards. Whenever you have the modulus on x, you reflect on the y-axis from positive to negative, and you remove anything that you already have on the left of the x-axis.